We've talked about how trees can be useful for organizing data and showing relationships or hierarchies. Another thing that we'll use trees for in class is for planning and thinking and anticipating, which will then allow us to make choices that are informed by that tree, by what we've learned from the tree. To start to think about that, let's think about how a human would approach playing a game and evaluating situations in a game like the tic-tac-toe game shown, where, in case you don't know the rules, the goal is to get three across, up and down, or diagonal of the same symbol for your player. So take a moment and think about the easy question: who is most likely to win in the tic-tac-toe game that's shown? But the harder question: how do you know this? And to start to think about how a computer might come to know something like that as well. So, who's likely to win? But even more beyond that, how would you know? Or how would a computer be able to learn the same sort of information that you have there? Pause the video. Think about it for a moment. There are probably two common ways that humans might answer a question like that. One of them will be feasible for a computer easily, and another one will be pretty complicated to get a computer to do. One is intuition, and that is you could look at this and kind of get an intuition that you might not be able to justify fully, but say that you think that X is most likely to win. And that's very hard to program into a computer. It can't look at a pattern and kind of recognize it the way that humans can, much as we've seen in some of our other examples like processing mathematical expressions in infix. But another way that people commonly would do this sort of thing is to think through what are the possibilities, so we can see whose turn it is, because O has fewer placements than X has, so it must be O's turn. And O has only 4 possible choices from here. O could choose to place in any of these 4 locations. For instance, O might choose to place here and block X from getting that spot. But if O places there, then X can place down here the next turn. And so now we're thinking multiple steps into the future, but we can see that O would lose and X would win in that case. And similarly, O could place here to try to block, but then X will place over here in the next turn. And if O does neither of those and places in one of the other locations, X has 2 options to make in the next turn to try or to win. So not only is it likely that X will win, but it's certain. And we can prove that exhaustively by thinking about what if O placed here, or here, or here, or here, and step forward into the future in our thinking. And that's a task that a computer can actually pretty easily do. It may take time and it may take memory, but it's not necessarily difficult for a computer to think, what if this, 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 and this? We saw that with some of our backtracking algorithms before. But we're going to need to be a little more exhaustive about things and a little more deliberate about things than we were before. We're going to have to use a tree to represent those possibilities, where we start in the reality of the world we're looking at with the X's and O's here. And then we think about each of those possibilities branching off from this like a tree. And that there are 4 possibilities. O could place in any of these 4 spots. And so we could create each of those possibilities. And then from each of those, look at all of the possibilities of what X might choose to do. Now, there are possibilities that are sort of absurd. A bad player might place an O here or here. And likewise, a bad X player might place an X in a location that doesn't win for them. And the computer won't have that intuition behind it. So we're going to have to help the computer think it through all the way, all of the possible choices. And if it does, then we can select the best move for our situation. And the advantage that the computer is going to have over a human is that from even larger sets of possibilities, the computer is going to be able to think those all through very quickly, not miss one of the possibilities if it's a game with a limited number of possible moves or choices, and to remember all of them for much longer than a human could. And so you're going to look at some ways that a computer could represent a game like this, could think about the possibilities within it, and could think about how you could attempt to evaluate what are good moves and what are bad moves as you go through the activity with parts A and B today.